Decoding the future of AI. Welcome to AI Perspective. What if an AI could draw, not like a machine, but like a master artist? What if it could start with a rough idea, a simple shape, and then refine it, layer by layer, into a masterpiece? And what if it could do it all in half the time? Just this week, ByteDance dropped a model that does exactly that. Meanwhile, Alibaba shattered the language barrier, open sourcing a set of tools that completely redefines how our machines understand us. And in the United States, researchers finally figured out how to teach a chatbot the 3 most important words in artificial intelligence. I don't know. The pace of AI is no longer just fast. It's becoming fundamentally better, more efficient, and way more real. You're not going to want to miss this. Let's get into it. Let's start with ByteDance. Their researchers just pulled the curtain back on a project called DetailFlow, and it completely flips the script on how AI generates an image. For years, most image generators have worked like a slow, meticulous printer. They treat a picture like a giant checkerboard. They start at the top left pixel, move to the right, hit the end, bounce down a line, and repeat. From DALL-E to Midjourney, the core idea has been to predict these little patches, or pixels, one after another in a grid. This raster scan method is fine for simple images. But it's incredibly inefficient, think about it. Even a standard 1024 by 1024 image, about the size of an Instagram post, forces the AI to make over 1 million decisions. To manage this, models use tokens, which are like words for images. A powerful model from last year called Infinity needed over 10,000 of these tokens to render a single picture. Imagine trying to read a book, one character at a time, just to understand the story. That's the level of painful inefficiency we've been dealing with. Even newer, smarter methods like VAR and FlexiVAR, which can sort of zoom in and out as they work, still burn through nearly 700 tokens for a tiny 256 by 256 square. For anyone hoping for real-time graphics in a video game, or a photorealistic avatar on a video call, this is a massive bottleneck. It's a traffic jam on the information superhighway. DetailFlow's creators asked a brilliant question. Why are we teaching an AI to be a printer when we could teach it to be an artist? When a human sketches, they don't start in the top left corner and render every eyelash perfectly before moving to the next pixel. They start with big, broad strokes. The general shape of a head, the line of the shoulders, the overall composition. Then, they progressively add detail. The eyes, the nose, and only at the very end, the tiny things like hair strands and reflections. This is exactly what DetailFlow does. The team built a revolutionary new tokenizer. Instead of breaking an image into a grid of squares, it breaks it down by layers of detail. The process starts with a blurry, low-resolution version of an image. The very first token represents this coarse, fuzzy blob. The next token adds a layer of clarity. The next token sharpens it further. Each token in the sequence equals one more notch of detail. Because the whole process flows in a single line, one-dimensional instead of a two-dimensional grid, the results are staggering. To create a 256 by 256 image, DetailFlow needs only 128 tokens. Let me repeat that, the old way, almost 700 tokens. The DetailFlow way, 128. That is a more than 5-fold reduction in complexity. But is it any good? This is where it gets crazy. In AI art, we measure how real a fake image looks using something called an FID score. The lower the score, the better the image. DetailFlow, with its tiny 128 tokens, scores an FID of 2.96. The 700-token VR model it's competing against, it scores a 3.3. So, ByteDance's model is creating better images while using less than 1/5 of the computational words. That is a genuine mic drop moment in generative AI, and it gets better. Dial it up and let DetailFlow run to 512 tokens, and its FID score drops to an incredible 2.62. But quality is only half the story. The other is speed. This is where that coarse-to-fine sketching method really pays off. Because the first tokens define the big picture, and the later tokens handle the fine-tuning, the network can predict several tokens at once in parallel. The model can basically say, I know the first part is the sky and the bottom is the grass, so I can start rendering the texture of the clouds and the blades of grass at the same time. Now, this kind of parallel guessing usually creates problems, visual glitches or potholes where the AI's guesses clash. But the ByteDance team baked in a genius solution: a self-repair drill. During training, they deliberately mess up some of the early, big-picture tokens. They introduce a glitch. Then they force the later, detail-oriented tokens to not only add their detail, but also to first notice the mistake and patch it up. It's the digital equivalent of an artist stepping back, seeing a smudge, and seamlessly correcting it on their next pass. And we know it works. In an experiment where they turned this self-repair function off, the model's FID score jumped from a clean 3.68 to a fuzzy 4.1. That proves the patch-up routine is essential. When you combine fewer tokens with these parallel bursts of computation, DetailFlow generates images almost twice as fast as its competitors on the exact same hardware. If you've ever stared at an HD upscaling progress bar, you know that cutting that wait time in half is a monumental leap forward. It means more time for creating and less time for waiting. For interactive design, this is a holy grail. You can generate a lo-fi preview in milliseconds, decide you hate the composition, and throw it away before a single computational cycle is wasted on rendering the eyelashes. Okay, put your paintbrush down and pick up a library card, because our next story is about how AI understands words. Alibaba's Qwen team just went public with their new Qwen 2 embedding and re-ranker models, and they are a seismic event in the world of open-source AI. If you've ever typed a half-remembered song lyric into Spotify or searched your company's Slack for that one doc from last month, you've used embeddings. They are the magic that converts words, sentences, and ideas into numerical representations, or vectors, that a computer can actually understand and compare. They power modern search, recommendation, and the retrieval augmented generation, or RAG systems that let chatbots look things up. For a long time, the best, most powerful embedding models were locked away behind expensive APIs from companies like Google and OpenAI. If you wanted the best, you had to pay up. Qwen 2 blows the doors off that paywall. They've released a whole family of models, from a small one that can run on a laptop to a massive server-grade powerhouse, and they're all released under the Apache 2.0 license. That means you can download them, tweak them, build a commercial product on top of them, and sell it. They are completely yours. And they are astonishingly powerful. They handle 119 languages right out of the box. We're talking French, Marathi, Yoruba, even programming languages like PHP. The benchmarks are stunning. On MMTB, a massive test covering over 200 languages, the largest Qwen 2 model scores a 70.58, dethroning previous champions. On the English-only MTB benchmark, it slips just ahead of top models from NVIDIA and Google. For developers, the MTEB code test is critical. It simulates finding code snippets on GitHub. Qwen 2 nails it with a score of 80.68. That's money for anyone building a developer tool. So how did they do it? It's a mix of clever architecture and a brutal training regimen. Instead of averaging out a whole sentence to find its meaning, Qwen 2 grabs the vector from the very last token, the end-of-sentence marker. It's like summarizing a paragraph by focusing on its final conclusive point. The training is a three-step relay race. First, they used a giant AI to generate 150 million synthetic flashcards of questions and documents. Second, they cherry-picked the best 12 million of those pairs and fine-tuned the model on high-quality data. Third, they melted several different versions of the model together, finding a perfect sweet spot in the middle that excels at everything, rather than just one specific task. The result is a set of open-source tools that are truly world-class, democratizing a foundational piece of the AI puzzle for everyone. So we have AI that's faster and understands our language better. But there's a deeper problem. Can we trust it? Everyone loves the fine-tuning process that makes models like ChatGPT so coherent. But that process has a dark secret. It silently punishes a model for ever refusing to answer a question. and AI doesn't get reward points for saying, I don't have enough information. Researchers at the University of Southern California call this the Hallucination Tax. As models get better at sounding human, they lose their instinct to back off when they're out of their depth. Their refusal rate drops to nearly zero. So they start filling the gaps with confident-sounding nonsense. This is incredibly dangerous in fields like medicine, finance, or law. The USC team's fix is both simple and brilliant. They created the Synthetic Unanswerable Math Dataset, or SUM. They started with regular math problems. Then they fed each one to another AI and gave it a simple instruction. Break this. The AI would subtly mess with the problem, removing a key variable, swapping units halfway through, or inserting a flat contradiction. The result is a set of problems that look completely plausible, but are logically impossible to solve. Then, they mixed this 10% of unanswerable problems in with 90% normal problems during the fine-tuning stage. They explicitly taught the model to output "I don't know" or a similar refusal when it detected such a trap. It forces the model to actually reason about whether a question is solvable before it even tries to answer. The payoff is massive. A Quen model that started with a refusal rate of essentially zero learned to correctly refuse an impossible problem 73% of the time. Llama 3 saw a similar jump, rocketing from 0% to 75% refusal on the same test. And the best part? It didn't make the models dumber. Their accuracy on solvable math problems changed by less than 0.5%, basically statistical noise. This means we can teach AI caution without making it clueless. It's the training data equivalent of putting a sticker on a car's mirror that says, "Objects may be wrong, double check." It's a minimal, cheap, and profoundly effective change that makes you wonder why this wasn't standard practice from day one. So let's put it all together. ByteDance is making AI creation faster and more intuitive, mirroring human creativity. Alibaba is making elite AI understanding open and accessible to the entire world. And USC researchers have laid out a simple blueprint for making AI safer and more honest. This is the cutting edge. Speed, access, and safety. These aren't just lab experiments anymore. They are foundational shifts that are happening right now, creating a new generation of AI that is more powerful, more reliable, and in the hands of more people than ever before. The future isn't just coming, it's being built, token by token. If you learned something new today, toss a like on this video. And I have to ask, which of these breakthroughs do you think will have the biggest impact? Let me know in the comments below. Thanks for watching, and I'll catch you in the next one.